This video here is a nice number theory problem. It's coming from the Serbia Mathematical Olympiad edition 2009. Here is the following setup. We are going to determine all x, y, z as a pair of the solution, which is satisfy this following equation. We get 3 to the x minus 5 to the y equals perfect square, which is z square. Okay. In fact, this problem is so exciting to work on. So you guys, you can give the hand to this problem prior to the solution. Go ahead, pause this video anywhere you come back to see the solution. Okay. Now let's jump into the solution. So I'm going to introduce here two methods. The first method, I'm going to apply the regular method, but the other one is going to be a more powerful tool. Okay, which is lemma is called, which is left-hand exponent. Okay. Now the method number one, I'm going to check the parity of x. Okay. So I'm going to reduce the equation to the mod 4. Okay. So I'm simply by reducing this equation to the mod 4, this one is definitely is a congruent to 0 mod 4 because we know this difference is even. Okay. So this one is going to give us minus 1 to the x minus 1 is a congruent to 0 mod 4. Okay. Because you get 3 equals 4 minus number 1. 4 is 0. Okay. I'm going to move over this minus 1 to the right over the congruence. Minus 1 to the x is a congruent to 1 mod 4. Okay. X is definitely is a even. Okay. If this one is a even, I'm going to put it on this form. X equals to m. Okay. I'm going to take this value of x and insert it back into the original equation. Then move over this term to the left and make the difference of the squares. And also we are going to move over this 5 to the y to the right. The factorization that we are going to make is going to be a power of 5. Okay. So I get here 3 to the 2m minus z squared, which equals 5 to the y. So I'm going to factor out on the form of the product here. So I get 3 to the m minus z, factor 3 to the m plus z, which equals 5 to the y. Okay. Each term of this product is going to be a power of 5. Okay. Now, let's express that on the form of the equation system. So I get 3 to the m minus z equals 5 to the a. The other one is going to be 3 to the m plus z, which equals 5 to the b, where is b strictly superior than a. It's more simple. I'm simply going to sum these two equations. I get 2 times is multiplied by 3 to the m. I get z is going to be cancelled out due to the different sign of same integer. So I get 5 to the a plus 5 to the b. So you know that a is smaller than b. I'm going to take 5 to the a as a common factor. I get here 5 to the a factor 5 to the b minus a plus number 1. Okay. But notice here 5 is supposed to divide the left hand side of this equation. Notice here 5 divides the right hand side of this equation, which means 5 must divide the left hand side of this equation, which is impossible because 5 cannot divide 2 and 5 also cannot divide 3. So let's notice that 5 cannot divide 2, also 5 cannot divide 3 to the n. This one is definitely is going to be a must be 0. Okay. So I'm going to reduce this. I'm going to simplify this equation more. 2 is multiplied by 3 to the m, which equals 5 to the b plus number 1 because a was 0. Okay. So here is the issue now. If you take a look at here, if m is superior to 2, which means this term is going to be divisible by 9. So we are going to reduce this equation to the mod 9. Okay. Let's do that. If m is superior to 2, 3 to the m is a congruent to 0 mod 9. Okay. So which means 5 to the b is a congruent to minus 1 mod 9. Okay. So we need to take the chart to see what's the possible values of the power 5 when you reduce this one to mod 9. Before we move on to the chart, I'm going to determine the parity of b first. Okay. The parity of b here, if I'm going to reduce the equation to the mod 6, we will be able to determine the parity of b. Okay. To put the 6 here in the front, so I get 6 is multiplied by 3 to the m minus number 1. Okay, by extracting one of the 3 is multiplied by 2 is going to give us 6, which equals 5 to the b plus number 1. So by reducing this equation to mod 6, so I get 5 to the b plus 1 is a congruent to 0 mod 6. So 5 to the b is going to be minus 1 to the b plus 1, which is a congruent to 0 mod 6. Because 5 equals 6 minus number 1. Okay, I will get minus 1 to the b is a congruent to minus 1 mod 6. Okay, so the b must be odd here, because if b is odd, is automatically is going to have minus number 1 here. Okay, now let's get rid of this one and move out to the chart. Okay, now we are going to determine the possible values of 5 to the b. So I already reduced the equation to the mod 9. We have ended with a remainder of minus number 1. We are going to check where we have minus number 1 as a remainder. Okay, here. So the first value is 0, it becomes 1. 5 to the 1, which is 5. 5 square, which is 25. 25 is 2 less than 27, which is minus 2. Because we know 27 is we know 9 divides 27. So for the 3, I'm simply going to multiply 5 in each term here. So 5 is multiplied by 2, which is minus 10. Minus 10 plus 9, which is minus number 1. I get a remainder, minus number 1 here. Minus number 1 is multiplied by 5, is going to give us minus 5 here. Minus 5 is multiplied by 5, which is minus 25. Minus 25 plus 27, I get a remainder 2. Okay, so 2 is multiplied by 5, which is 10. I get a remainder number 1. 1 is multiplied by 5, which is 5. 5 is multiplied by 5, which is 25. 25, we get 2 less than 27. So I get minus 2 here. Minus 2 is multiplied by 5, is going to give us minus 10. Minus 10 plus 9, which is minus number 1. So I'm going to change the color of this one to make it more clear. For 10, for the value 10, we get minus 1 is multiplied by 5, which is minus 5. Minus 5 is multiplied by 5, which is minus 25. Minus 25 plus 27, which is the remainder 2. 2 is multiplied by 5, which is 10. You get a remainder 1. 1 more 9. 1 is multiplied by 5, which is 5. 5 is multiplied by 25. We get minus 2 here. Minus 2 is multiplied by 5, which is minus 10. Minus 10. 10 plus 9, which is minus number 1. If I'm going to add another 3 values to make sure what we add when is right, okay, so let's add the values 16 and 17 and 18. Okay, so for 16, I'm simply going to multiply minus number 1 by 5. I get minus, we're going to give us minus 5 here. So we get minus 5 here. For the next value, guys, minus 5 is multiplied by 5, which is minus 25. Minus 25, I get a remainder 2, because 27 minus 25. 2 is multiplied by 5, which is 10. We get a remainder number 1. Okay, we got minus number 1 here. We get minus number 1 here. We get another minus number 1 here. But we still not have minus number 1 yet. Let's add another 3 values. Let's put 19, 20, and 21. So for 19, I get 5 here, the remainder. 5 is multiplied by 25. I get minus 2 here. Minus 2 is multiplied by 5, minus 25. 25, the remainder. Minus 2 is multiplied by 5, which is minus 10. Minus 10 plus 9, which is minus number 1. Now I got minus number 1 here. I did this one quickly because we have a lot of values here. I have to calculate it to check the remainders. So since we got minus number 1 here in number 3, I got minus number 1 here at 9, I got minus number 1 at 15, we got minus number 1 in 21. So from number 3 to 9, it differ by 6. Okay, from 9 to 15 differ also by 6. From 15 to 21 it differ by 6 also, plus this 3. Okay, which means that b is going to be written on this form: 3 plus 6n. Okay, what is the n? What is the n? Is super equal to 0. N is non-negative integer. So here So remember here, we need to take b must be superior to 3, because b is an odd. Also b equals 1 is going to be exceed the left hand side of this equation since m is superior to 2. Okay, so we are going to work on this assumption, b is superior to 3. Now let's take this value of b and insert it back into the original equation and keep working on this one. Okay, taking this value that I have found, I'm going to put it into the original equation. Before we do that, I'm going to take the number 3 as a common factor here. So we get b equals 3 factor 1 plus 2n. Okay, let's put this one into the exponent. So you get 2 is multiplied by 3 to the m, which equals 5 to the 3 is multiplied by 1 plus 2n plus number 1. Okay, this one is going to be written on the form of 1 plus 2n all is raised to the 3 plus 1 to the 3. I'm going to factor out that since we have a sum of 2 cubes. So I get the following. I get 2 is multiplied by 3 to the m. Since we get m is superior to 2, I can write this one also. This one equals 6 is multiplied by 3 to the m minus number 1. Also equals 18 is multiplied by 3 to the m minus 2. Now I'm going to factor out that. I'm going to factor out this one. So I get 5 to the 1 plus 2n plus number 1 factor 5 to the 2 is multiplied by 1 plus 2n minus 5 to the 1 plus 2n plus number 1. Okay, I have expressed this one on the nice form here. If you take a look at this product, so we know this product is an even, we know this one is an odd. Okay, so which means this one is going to take either one, this one or this one or this one, because we are absolutely free to express 3 cases, because since we get m is superior to 2, because if m equals 2 here, we still find we still have integer here. We have 18 is an even, okay, which is fine. But we cannot add another even, because you get, if you add another even here, which means you get m minus 3 in the exponent, which is impossible because we have m is superior to 2, because if m equals 2, this one is become not integer. Okay, so I'm going to take 3 cases. Case number 1, if 2 equals this one, 5 to the 1 plus 2n plus number 1. So this one immediately is going to give us 5 to the 1 plus 2n, which equals 1, implies 1 plus 2n equals 0. Thus 2n equals minus number 1. It's clearly, it's impossible. Okay, let's move on to the case number 2. We don't need to write this one in terms of this one, because this one is enough. Okay, because we are dealing with even. Even is taking even, odd is taking odd. We're going to do an extra work here. Okay, so case number 2, I will have 6 equals 5 to the 1 plus 2n plus number 1. This one implies 5 equals 5 to the 1 plus 2n, implies 1 plus 2n equals 1, implies 2n equals 0, n equals 0, which means b equals 3. N equals 0, which means b equals 3. If b equals 3, I'm going to replace it here. So I get 2 is multiplied by 3 to the m, which equals 5 to the 3, which is 125, 125 plus 1, which is 126. Dividing both sides of the equation by number 2. So I get 3 to the m, which is a power of 3, which equals 63. But 63 is not a power of 3, which is impossible. Now we are going to check the case number 3. I get 18 equals 5 to the 2n plus number 1 plus number 1, implies 5 to the 2n plus number 1 equals 17. Okay, this one 17 is not a power of 5, which is impossible. Okay, so we checked all the cases, none of the cases worked here, which means we have no solutions above this point. So which means only solution that we have, since we are dealing with positive integers, which means m must be equals 1. Okay, if m equals 1, I get here 6 equals I get 6 equals 5 to the b plus number 1 implies 5 to the b, which equals 5, b equals 1. Okay, so b equals 1, which means y equals b equals 1, because a, it was 0 before we are determined, because y equals b plus a is 0, a was 0, which means y equals b equals 1. We have determined y equals 1, and also we found x, which equals 2m, m was 1, which is 2. Now we have determined the pair of the solution. X was 2 and y equals 1. With z, it's more simple to find z, because we get here 9 minus 5, which is 4. 4 is the same as 2 squared, so z equals 2 here. This is the only solution that we have. This is the only solution that we have on the positive integers. So I have done with this method. I'm going to move over to the second method. Okay, the second method is not going to take us too much time, because it's more powerful and quicker tool here. So I'm going to apply the lifting exponent. I'm going to give you the quick definition. We get v of p of e to the n plus b to the n, which equals v of p a plus b plus the vp of the exponent. This is the definition, because before we apply this rule, we need to make sure p divides the sum of a plus b, or depends what you have here. If you have minus sign here, we get put a minus b. If you have plus sign, we get put a plus b. P is a prime. We are dealing with it. P is a prime. It could be even prime, it could be odd prime. So if you take a look up here, this one is going to be written on the same form that we have here. So this one, you will have 1 to the b. Okay, so let's apply this one on this one directly. So I get v of p. P here in this case will be 3. We know b is odd. B already was odd. Why 3 here? Because 5 plus 1, which is 6. We know 3 divides 6. Okay, so I get v of the lifting exponent of these two integers, 5 to the b plus 1 to the b, which equals the lifting exponent of 5 plus number 1 plus the exponent itself, which is b, but we have two sides of the equation. So this one will have the lifting exponent of 2 is multiplied by 3 to the m. This one equals v of 3 to the 2 plus v of 3 to the m. Let's expand this one out. This one equals 6. 6 is the same as 2 is multiplied by 3 to the 1. You get exponent number 1. So this one is definitely 0. Why is 0? Because 2 and 3 are relatively primes. Okay, so this one, by applying the lifting exponent rule, so this one equals to m, because we have the base 3, which means we are going to take only the exponents. So let's put this one down here. So I get here, this one equals 1 plus v of 3 to the b, which equals m. Okay, let's take this number 1 to the right. So I get v of 3 to the b, v of 3 of b as an exponent, as an lifting. We get this lifting exponent equals m minus number 1. So by applying the lifting exponent rule, I get b equals the base 3 to the m minus number 1. Now let's take this value of b, put it here, b equals 3 to the m minus number 1. Now we are ready to make a nice comparison between m and b here. Which one is bigger, which one is smaller here? If you take a look at the base, this base is small, this base is bigger. So we need to increase m to the highest value in order to make this equality, because if b is smaller here, m must be bigger than b, which means always m is superior to b. It could be equality, it could have equality here, because if m equals b here, if m equals 1, b equals 1, you will have equality. We have 6 here equals 6. Okay, which means this one always m must be superior to b. Okay, so we get this nice form, m is superior to 3 to the m minus number 1. Here is a problem. If problematic here. If m is super equal to 2, this one, the exponential form is always growing quickly than linear form. If we replace m with 2 here, we get 3 here, we get 2 is bigger than 3, which is impossible. This is impossible, which means we have no solutions above number 2. Immediately this one is telling us m equals 1. Okay, if m equals 1, we get us to this solution. Okay, directly replacing m with this value, and then we find the rest of other values. Okay, now I have done this problem. Thank you for watching. I will see you next video. Bye.